Hello everyone and welcome back to podcast number 15. This one right here, pretty proud of this one. So notice that these two are conjugates. Let me take a pause. First of all, if you tried u substitution, the u would have a sign. The derivative of that's cosine. There is no cosine in this problem, and because we don't have a sine squared, can't really get a cosine into the problem. Okay, next up, notice that these are conjugates of each other. So if I multiply this one by its conjugate would be 1 plus sine x. This one's conjugate would be 1 minus sine x. So then I had to think about it, and I tried one of them and it wasn't working out. Then I tried the other one and it looks like it's going to work. So this is my scratch paper right here. Okay, so I'm going to multiply by this one's conjugate, which is 1 plus sine x. You then need to do the exact same thing on the top, 1 plus sine x. So when you multiply on the top, you'll have 1 times 1. You'll also have sine x times 1 and another sine x times 1. So that's 2 sine x's. And we'll also have sine times sine, so we'll have plus sine squared. On the bottom, when you multiply, you'll have 1 times 1. And then the middle terms will cancel because this one is a negative sine times 1. This is a positive sine times 1, so they cancel. Then there's just the negative sine times positive sine, so that leaves negative sine squared. And now this can be simplified because 1 minus sine squared is cosine squared. So I can rewrite this as integrate a 1 plus 2 sine x plus sine squared all over just a cosine squared. Now, as it is, this is a pretty complicated antiderivative or pretty complicated integral to do. So what I'm going to do is I'm going to break this up into 3 fractions, 1 divided by cosine squared, the 2 sine divided by cosine squared, and then sine squared divided by cosine squared. But before I do that, as you can see on my little scratch paper right here, I said, you know what, you should replace this with 1 minus cosine squared. The reason for that being, then I would get a cosine squared on the problem. So rather than having to integrate sine squared over cosine squared, eventually I'll have cosine squared divided by cosine squared. That's what I was thinking. So this one is going to get replaced with 1 minus cosine squared. All right, now break this into 3 fractions. There is going to be a 1 right here plus a 1 right there. So there's going to be a 2. So 1 plus 1 is 2, in case you didn't know that. Haha, just kidding. So 2, and then its denominator is cosine squared. And then there's going to be this middle term, which has plus 2 sine x, and then it's divided by cosine squared. So that takes care of this one, and this 2 sine x. And all that's left is minus cosine squared over cosine squared. And then before you're doing the antiderivative, I'm just going to clean this up a little bit. Like 1 over cosine is secant. So this one is really secant squared. So integrate 2 times secant squared. Plus, this one can't really be simplified, and in fact I'm going to use u substitution on this one. So for now I'll just leave it 2 sine x over cosine squared, and then this is just a 1. And technically it's supposed to be in parentheses and then times dx. So this one will be easy. The antiderivative is just x. This one's easy because the derivative of tangent is secant squared, so that means the antiderivative of secant squared is just tangent. And then this one, just use u substitution. So for this one, let u equal the cosine of x. The derivative of that is negative sine x. And then I just need to get rid of the negative because this one doesn't have a negative. So negative du is equal to sine of x dx. So this sine of x is going to get replaced with the negative du. Now I do need to extend my paper. All right, the antiderivative of secant squared, that's tangent, and the 2 can just stay there. So 2 and tangent of x, and this one is done. This one becomes the u substitution. The 2 can be factored out, and the negative sign can be factored out, so there's going to be negative 2, and then integrate, and then on the top would be du, and then this would be u squared on the bottom. So I'm going to rewrite that as u to the negative 2 du. And then over here, the antiderivative would just be x. So the u substitution is only used on the middle one. This is just an x. And so I don't forget, I'm going to put plus c. All right, so 2 tangent of x is part of the answer, minus 2. And then for this one, just add 1 to the exponent, which is a negative 1, and divide by negative 1. So that's actually going to cancel this negative. And then it's going to leave u to a negative 1, or 1 over u. And then the last thing is replace u with cosine. So this is 1 over cosine. And you could leave it as 1 over cosine, but you could even simplify 1 over cosine as secant. So 2 tangent of x plus 2, and here you could either say 1 over cosine, or you could simplify and say that's secant of x, then minus the x and plus the c, and then box it up and send it in.